You can simply click on this, it will get a record. Okay, here I have taken a soil data. It consists of different kinds of soils, and based on certain kind of characteristics or variables. One is nitrogen, phosphorus, and potassium. For this, I have made this soil variable as a factor because it is a character variable here. We have three different kind of soils, so we have to, first thing we have to make it, you have to convert that into a factor. Then we have to use another library for creating this kind of a plot, that is ggally, Gally, and reshape, it is always there. Then ggpairs, if I will write the ggpair, it will get a paired kind of a relationship between this variable. Then followed by ggpairs, name of the data set, followed by the title ggpairs, whatever the title you want to write on our graph, you can simply customize it in your own way. Then following by colors, since this soil is a categorical value, we have three different kind of soil. So there are three different: blue, green, and almost maroon or red, something like that. Then followed by, then simply if you will run this by simply highlighting it, then clicking on the run, or simply you can put the cursor inside it and simply put click on the run, you will find out this kind of a graph here. Here three soils are represented by three different colors. As far as the nitrogen is concerned, this soil is having more variability in comparison to the rest of the tree. And again, if you see, it is having a huge amount of extent. The tails are more structured of this soil in case of phosphorus in comparison. So here you can simply compare the different kind of stuff, different kind of samples you have, different kind of varieties you have, different kind of machines you have, and different kind of soils in this case you have. Then followed by another thing, that is the density plot here. You can see what kind of peakedness, what kind of bulkiness, how scatteredness, what kind of structure my data set is having. Then again, if you will see, these are the simple dots. As you see, these colors reflect the type of the soil. You can see the scatteredness, and these are some kind of histograph. But this is more important. If you want to know the correlation between two variables overall across the three soils, you have a correlation of 0.38, 3.90, which is significant correlation between phosphorus and nitrogen. But if you find the correlation between phosphorus and nitrogen within the soil, what it is something different. It may be different. Depends. Okay, you may have different, but the main thing here is you will get the overall correlation, and within the samples, since the red reflects this kind of a soil first, and it's got a different correlation, and it's got this much of correlation, it's got this much correlation. So this graph, this is ggpairs plot, which is from ggally, and this is one of the most commonly used plots as far as this ggplot library is concerned and ggla library is concerned. This is the most, I guess, in my opinion, it should be used in your way, because you may having different kind of treatments where you want to evaluate them based on certain kind of variables, based on certain these kind of characteristics. And the normal traditional designs you use to compare different kind of treatment. You can use this kind of graph, and the previous graph which I have shown you, where you can reflect the p-value of ANOVA. So my point here is that these kinds of things, they are more attractive. They are more attractive in the sense in comparison to the traditional tables we used to make. When we finalize our results. The point here is that means data visualization plays a very important role as far as your research publications are concerned, or whatever the projects you want to make. So you should give more emphasis on data visualization because it will fetch you definitely a very good publication also. Then I have taken a very another data set that is made up of different type of genotype, which you may be aware of because you are dealing with these kind of data sets. We have different kind of genotypes, and we have 1, 2, 3, 4, 5, 6 kind of variables. And again, I have highlighted it and copied it, and we have made this kind of a plot, which is a correlation plot. For that, what you have to do, you have to use some kind of libraries. Okay, library core plot is one of the libraries which is recommended for this kind of plots. Okay, then I have written this read.table, or you can simply import from that. Okay, this is the correlation plot. It is value, as you know, it is from -1 to +1. It is in correlation. Its maximum range is from -1. So blue, if it is more denser from the blue side, it is